G'day guys, we've got a chemistry question today for you. More specifically, we are titrating strong acids with strong bases and to try and work out what the concentration is of, in this case, a strong acid. So let's have a look at what we have. It takes 38 mils of 0.75 mole per litre sodium hydroxide solution to completely neutralise 155 mils of a sulfuric acid solution. What is the concentration of the sulfuric acid solution? Okay, so whenever we're doing these sort of questions, we should start off with a balanced equation of what is going on when we mix sodium hydroxide with sulfuric acid. So the way it's going to work is if we have sodium hydroxide, so we have Na, OH, and we're adding to that H2SO4. And a acid plus a hydroxide gives a salt, which in this case is going to be sodium sulfate. So we've got Na2SO4 plus water. So let's go ahead and balance this. To get the two sodium atoms, we're going to need to double this. And if we double this, we're going to have to double the amount of water that we're getting as well. And let's just see, we have 4 hydrogens on this side. We have 1, 2, 3, 4 on this side. The oxygens are okay, and so are the sodiums. So that's good. We could also write this as a ionic equation, but you get the gist with this. So basically, the reason that we write the initial equation out is to get our molar ratios of our reactants. So we know that 2 moles of the sodium hydroxide reacts with 1 mole of H2SO4. Now, no, I wouldn't write this in an exam or a test situation. It's not really necessary, but this is for your benefit, so you can see exactly where I'm going with this question. So the next thing we're going to have to do is, because all of these are in moles, we're going to have to work out what 38 mils of this concentration, how many moles of it we actually have. So let's start with going the number of moles of sodium hydroxide is going to be equal to the concentration times the volume. That's our little formula. So this is going to equal the concentration, which is 0.75, times the volume in litres. So this is where a lot of students will come undone, is we must write this 38 mils in litres. And if we get that, what we're going to have is we're going to have great. So if we have the number of moles of sodium hydroxide, we use this molar ratio to work out the number of moles of sulfuric acid that this many moles of sodium hydroxide would be able to neutralize. So what we then do is we know that it's a 2:1. So if we have one of these, it's going to be a half. So we're going to halve the number of moles of sodium hydroxide. So the number of moles of H2SO4 is going to equal half times the number of moles of NaOH, which is equal to 0.01425. Great. So once we've done that, all we have to do now is use this along with the amount of the solution that we have to work out the concentration. So we know that the concentration of H2SO4 is going to be equal to the number of moles of H2SO4 divided by the volume of it that is contained within. So this is equal to 0.01425 divided by the volume, 0.155 litres. And that, my friends, is equal to 9.19 times 10 to the negative 2 moles per litre, or 0.0919. You can write capital M. These two, I would say, units, moles per litre, and the capital M are interchangeable for volume. So let's just have a look at what we've got, or how we solved this in the end. First of all, we worked out that we have a sort of a beaker, so to speak, I would say. Let's say we have a beaker and it is filled with H2SO4 at a particular concentration. But the concentration of this is unknown. What we have is we have in some sort of burette above it, we have sodium hydroxide. And the concentration is known. The number of moles is known as well. So what we can do is we can use our knowledge of the reaction between sodium hydroxide and H2SO4 to, if we know these two things, we can then solve for this using the number of moles of H2SO4 and then the volume of it, because the volume of this is known. So basically what we do is we use the characteristics of all of the known substances to infer what we don't know, the characteristics of the well, this is an unknown. We know it's H2SO4, but we don't know what strength it is. So guys, I hope this video helped. If it did, give it a thumbs up. I try my best to put these videos out. It's not easy, I promise. And if you can, subscribe to my channel. Do us a favor. That'd be great too. But until next time, guys, keep practicing and enjoy your chemistry.